Hello and welcome to my talk on Texas English on Twitter, beyond lexical-geographic variation. This is a talk on Texas English dialectology and also on using Twitter data to get at some questions. And maybe you've noticed there's another talk on a very related topic in this panel by Alex Rosenfeld and Lars Hinrichs. That's really the more important talk. It's basically mine is a spin-off, kind of builds on a lot of what especially Alex has done in his dissertation, and uses his data. So I'm very grateful that he shared his data with me, and also from the audience's perspective, it probably makes sense to watch their talk first. I'm going to reference their talk a little bit in mine here. So anyway, thanks Alex and Lars. And let's get going. So I'm going to talk a little bit about Texas English dialect areas, what's been said about them, what's difficult about them, and then I'm going to talk about Twitter as a tool for modeling geographic variation. I'll present the data and method used in my exploratory study here, and then the analyses are going to be lots of maps of Texas, showing different color codings for different patterns of linguistic variation, and also plots of coefficient estimates for models predicting patterns of variation based not only on geography but on social factors. And I'll round it up with a discussion and some conclusions. So in the beginning of the second half of the 20th century, it was a popular sport to create Texas English dialect maps, and Underwood sums this up not in favorable terms as a number of linguists have sliced up Texas into different dialect areas despite a paucity of evidence to justify such carving. So he refers to these linguists as word carvers, and funnily enough, one of the people he mentions is called Carver as well, whom you see in the top left panel of the figure here. This is also taken from Underwood, and it just showcases the divergence between different authors' ideas of what the Texas English dialect areas are. So there's a lot of skepticism in Underwood of this enterprise of drawing maps of Texas English. But despite that skepticism, there are some things that general agreement seems to be obtainable about. So there's a general notion that there's a distinction between Eastern and Western dialect regions in Texas, going back at least as far as Atwood, 1962. And it's reflected on this map here to the right, which is a map from the Perry Castaneda Library, kind of synthesizing a number of sources. You see in it's very small print in the bottom right corner of the map. So yeah, you see a general east-west pattern there as well. And then more recently, there's an increasing urban-rural split that's been observed, so that the cities appear to be developing in different directions linguistically than the countryside. And from a perceptual perspective, there's evidence that Texans themselves very much perceive of Texas English as not one undifferentiated whole, but that they believe people speak quite differently in different areas of Texas. So there's reason to believe that it's worthwhile looking a bit more deeply into what kind of linguistic differentiation exists in Texas. And when it comes to the paucity of evidence that Underwood mentioned in 1990, one way of addressing that is obviously collecting large amounts of data, and for that Twitter has become a very sought after or very popular tool, especially when it comes to looking at patterns of geographic variation, for the obvious reasons that it provides incredibly large amounts of data. They're unelicited, which doesn't necessarily mean they're vernacular, but certainly large amounts of data. That data comes at a very fine-grained level of both geographic and temporal resolution. So at least for geolocated tweets, you can situate them precisely at the point on Earth where they've been sent from and the time that they've been created at. And at a more methodological level, the data is born digital. It already exists in a structured digital format, which lends itself to further downstream analysis in comparison to some maybe more traditional dialectological survey data. There's equally important downsides, obviously, to working with Twitter data. So one of the biggest ones, I think, is sparsity of demographic information. So for any individual user, Twitter doesn't provide the typical census level categories like gender, age, ethnicity, let alone social class. So you need to find ways of operationalizing that in hopefully a meaningful way. There's also a big issue separating signal from noise. So there's bots, just for example, posting the weather forecast every day on Twitter. You probably want to exclude that. Retweets are problematic because they might be authentic material, but material created by another user rather than the one who retweets. And foreign language material is also very tricky, especially in a place like Texas where you're going to have a lot of Spanish. And at the same time, English. The English on Twitter isn't all going to be in a standard English dictionary. So drawing the lines between what's an English tweet and what isn't an English tweet isn't trivial. And then there's, at a more theoretical level, an underexplored relation between what's going on in terms of variation on Twitter and offline language use. I think there's a talk on this topic in this panel as well. From the evidence that exists so far, I think it's fair to say that at a very general level, one can expect correlations between offline and Twitter variation, but it's certainly something that I think a lot of people would like to see more evidence, more direct evidence of. Here's one example of how to use Twitter for establishing dialect areas of Texas. So this is Alex Rosenfeld's dissertation work, in which he constructs word vectors, so models of word use on Twitter in which every word is represented as a vector in a high-dimensional vector space, and all the Texas voting precincts, so small social units, small-scale social units, are also represented as vectors in the same space. And the vectors for the voting precincts are calculated based on the words used in tweets from that precinct, both in terms of their frequency and their collocational behavior. And then a big part of the method, which I'm only referencing here, go watch Alex and Laz's talk to learn more about it, is incorporated exponential smoothing. And that's a method designed to deal with data sparsity, so with the fact that there's a lot of precincts where not a lot of tweets are sent from, and also increase and smooth out the geographical signal. Again, watch their talk there. That's all about the method. Really. And the result in his dissertation, in Alex's dissertation, looks like this. So this is taking the vectors for all the voting precincts and subjecting them to cluster analysis, and then just giving each cluster a separate color. And there's a lot that could be said about this map. I'm going to restrict myself to saying that it shows very clearly both a east-west divide, right? The west essentially is just a bunch of yellow, and the east is a bit more differentiated, and also the cities all appear as separate clusters. So the urban-rural divide is there as well. And I'm tempted to say some things about the more interesting patterns with San Antonio, Laredo, and El Paso, and also College Station here, but I'm not gonna, because it's not my topic and I don't have time to talk about it. So this is a really, really great and impressive map. It shows precise boundaries, and that's what the method is designed to do, to establish these boundaries with incredibly large amounts of information, looking at all the word usage in all of Twitter from Texas. What the method isn't really designed to do is to make these differentiations, these different clusters, interpretable. So we can see that a person from Tyler is in a different cluster than a person from Laredo, for example, but the method doesn't make it, doesn't really allow for a lot of inference about what about the language these two people use is it that makes them different, essentially, right? So this is where my research questions come in. I'm interested in looking at the data from a more feature-centric perspective, so not just all words, but or yeah, not all words, but a select number of features that you know are attested to play a role in differentiating English either along dialectological lines or in terms of register. And what kind of patterns does that give us? And interpreting this not only in relation to geography, which is the strong factor in Alex's work, but also what social factors account for the variation that we find. So I'm using the same corpus as used in Rosenfeld's dissertation, which I don't filter down any further. So it's 3.15 million geolocated tweets, amounting to just short of 50 million words. And each tweet is mapped to one of the about 8,000 voting precincts in Texas. Those are social units of about just over 1,000 residents, 1,100. And we have information about voting behavior in these, percentage of different ethnicities in the population, and population density, which are going to be the social predictors of the linguistic variation we see in the data. And then for each voting precinct, for the sum of all tweets from that voting precinct, I extract the frequency information for 80 different linguistic features using a fairly broad approach. So I'm looking at features both from the dialectological literature, like sort of cliche, stereotypical southern features like y'all, fix into register features like the frequency of personal pronouns, nominalization suffixes, and features of computer-mediated discourse and Twitter, like emojis, hashtags, user mentions. And so then I have a data matrix with 80 columns and about 8,000 rows, one row per voting precinct. And the assumption is each of the linguistic features isn't just an island unto itself, but typically they will co-vary to a large extent, right? Texts with lots of pronouns will typically have shorter words, not show as many passive constructions, etc., etc. So there's a lot of covariance expected in the data, and with that covariance, it becomes possible to reduce these 80 features down to a much lower set of dimensions that capture the general differentiation in the data. So specifically, factor analysis does that. It essentially condenses the information into a lower set of dimensions. It scores each voting precinct along each factor, and for each factor gives us the strength of association for the linguistic features with that factor. And that's really useful because it allows for comparison, for example, at the geographic level between the voting precincts. But once we see that there's a difference, for example, between East and West, it also allows us to look at, well, what are the linguistic features that most strongly drive that differentiation? So it lends itself to interpretation. And I use the results from factor analysis for visualization to create lots of color-coded maps of Texas. So here's just an initial overview without any factor analysis. This is just the result of hierarchical clustering over the 80 features, and each voting precinct is assigned to one of 4 clusters, color-coded here. And even with that relatively coarse measure, we already pick up both the urban-rural and the east-west signal, I would argue. So the light brown precincts shaded in light brown, tend to be urban areas, and the darker shades of green tend to occur in the west of Texas, and the lighter shades of green in the east of Texas. And then probably the dark brown is less easily interpreted, but they tend to occur in close proximity to lighter brown, so they maybe these also may be picking up an urban pattern or maybe a suburban pattern. But there's really no reason to stick to a hard clustering solution, because if we express the variance in all the 80 features in a three-factor solution, we have basically values for each voting precinct along 3 dimensions, 3 factors. And those are continuous, right? And you can scale these and then use them as saturation values on an RGB, red, green, blue scale. And that gives a more, continuous, more finely graded picture of the variance in the data, where you aren't forced to subscribe to a given number of clusters. And that's what that looks like. Arguably, arguably showing something very similar to the previous picture, right? Everything that's in really dark shades tends to be the urban areas, and then there's also an east-west differentiation where the west of Texas has a lot more yellow and the east has a lot more pinkish colors. Now, so far we're looking at general tendencies that largely, confirm what we already know to some extent. What I'm interested in is really interpreting this general picture in terms of what drives the differentiation and teasing apart the urban-rural and the east-west signal. So for that, we can look at the individual factors, and I'm just going to look at factor 1 and 2 because I don't have time for the third one. It explains much less of the variance in the data, and it's not as easily interpretable. So we'll just look at factor 1 and 2, and we'll plot the values, the scores just for that one factor for all the voting precincts, and then we'll look at the features associated with that factor, and also at coefficients from models predicting factor scores based on precinct demographics to get at the social information beyond geography. Shifting to a slightly more pleasant color scale, this is factor 1, where the lighter yellower color indicates higher scores and blue dark colors indicate lower scores. And to interpret this map, I think it's easiest to place it next to a map showing the log population density across the voting precincts, where you can really see that there's a strong correlation, certainly for the big cities, but even for the smaller cities like for example, Lubbock. You see Corpus Christi down here, right? It really picks up that population density signal, which is essentially a measure of urbanness of a precinct, right? Which is nice. Very clear pattern associated with this factor. In terms of interpreting it, the most strongly associated features all have to do with an increase in elaborate information-focused discourse. So lots of Latinate affixes, both pre and suffixes, clausal subordination with if and unless, and amplifiers.
Yeah, and so the overall interpretation here is that these all indicate a slightly more elaborate style. And when we predict factor scores for factor 1 based on social demographic information, the coefficients look like this. So population density is a driving factor. We've kind of established this already. Ethnicity is statistically significant, but with relatively low effect sizes, so probably not something to emphasize here. And the second most important predictor next to population density is percentage of the Republican vote in a precinct. So the higher the percentage of Republican vote, the lower the factor 1 score for that precinct is going to be. And moving on to the second factor, this is the picture we see. Much more clearly an east-west picture, I would argue. It doesn't fully correspond to the line in Rosenfeld's data, so the line is shifted slightly to the west, but it's still, compared to factor 1, which picks up the urban-rural differentiation, I think this picks up the east-west differentiation pretty well. So it's nice to be able to tease these two aspects of linguistic differentiation apart. And it also has a very clear set of features associated with it, both first and second personal pronouns, contractions, user mentions, exclamation marks, all very sort of conversational interpersonal features. And predicting the factor scores shows model coefficients very similar to those for factor 1. So population density still being the most important and pointing in the same direction. Ethnicity, both black and Hispanic percentage in a voting precinct, slightly more significant maybe, and also pointing in a similar direction. And the differentiation is really Republican, percentage of the Republican, well, percentage of, yeah, Republican percentage, how many people vote Republican essentially, which shows an opposite effect compared to factor 1. So that's interesting that politics is a differentiating factor here between factor 1 and 2. All right, moving on. I think the analysis, even though it contains much less information in a way than what, for example, Alex Rosenfeld is doing in his work, it's still able to pick up on the general patterns of differentiation in terms of urban-rural and east-west. And also we've seen at least a glimpse of some of the effects that maybe, or linguistic differentiations that may lend themselves to interpretation. So there's a distinction between urban voting precincts showing a slightly more elaborate information-focused style compared to rural ones, and East Texas showing a slightly more conversational and involved style to West Texas. But we also need to take demographic factors into account, and one challenge is to combine both the demographic and the geographic perspective and not kind of privilege one at the expense of the other. And much more work is also needed for interpreting the dimensions. Like, I've really only shown the most associated features. You probably want qualitative situated analysis of examples, and ideally also establish these dimensions at the individual tweet level and not just at the voting precinct level. But those are avenues for future research. Here are my references, which you can pause the video to look at them, and also the features that I used, that I extracted from the data. Again, you can pause the video. I'm running out of time, over time already. So I'll stop here and say thank you for listening, and I look forward to whatever kind of discussion is going to develop from this.